right, ladies and gentlemen, I am going to be doing two examples with Le Chatelier's principle and concentration. So remember, we've got our two general rules here. We say that if concentration increases, then equilibrium is going to lean away from that species. And if concentration decreases, then equilibrium will lean towards that species. So what exactly does that mean in practical terms? So to help you understand this a little bit better, I'm going to be using some blocks and this generic equation. So in this generic equation, the red block is going to represent chemical species A, the blue block is going to represent chemical species B, and the purple 2 block is going to represent chemical species AB, which is created when an A and a B collide together. So right now, this is at equilibrium. We've got two A's, an A and a B, and then an AB right here. Now I'm going to go ahead and I'm going to double my concentrations of all of these, because if these were in a chemical reaction, of course we would have lots and lots of molecules moving around. So we'd have to imagine that all of these are constantly moving and changing, and that as AB collide together, a new purple block of the chemical species AB is formed. And as two purple AB blocks collide together, we would expect that two individual A's and B's would also form. And this process would keep going back and forth. We would have AB collide together, forming purple AB, and so on and so forth. So right now, this is at equilibrium because my reaction that's forming this purple AB is equal to the reaction that's forming my individual A's and my individual B's. So every time an individual A and B collide together to form a purple block, purple blocks come together, collide to form these two. And so it goes back and forth and it's nice and balanced. So what happens if I want to increase the concentration of one of these chemical substances? So let's say I choose to increase the concentration of B. So I'm going to go ahead and I'm going to add 2 extra B's, 2 extra blue blocks here to this reaction. Now we have to keep in mind that all of this would be happening in the same container. And so all of these particles would be just moving around constantly, right? And even as I'm moving these blocks, notice that they are hitting and bumping into each other. When I increase the concentration of B, I am increasing my number of collisions. Now we know that not all collisions are going to be effective. The effectiveness rate of collisions depends on the chemical substances that we have. Some collisions require a really strong force and very strong collisions in order to form a chemical substance. So anytime that I increase the number of particles that I have, or we would say increasing the concentration, and concentration is a measure of how many particles I happen to have. Anytime I do this, I increase the likelihood that I am going to have an effective collision. So what happens is if the concentration of a substance increases, so I increased B, so there's 4 blue B blocks here, then the equilibrium is going to favor the production of these purple blocks right here. And so when the rule says that equilibrium leans away from that chemical species, it's saying that since B went up, there are going to be more collisions with A, and more collisions with A is going to lead to an increase in my product. So it's going to increase the chemical species that's on the other side of the chemical reaction, which in this case is AB. And that's simply because I've increased my number of collisions, and when I increase my number of collisions, then the rate at which I produce the chemical substances on the opposite side is going to go way up. So we say it leans away or favors the production of the compounds on the opposite side of whatever I increased. And that's simply because the collisions themselves have become more effective just because there's more of them present. All right, so let's take a look at this second scenario here. So let's think about what would happen if I were to decrease the equilibrium. So let's say I start off with 3 of all of my chemical substances. 3 of everything. Now, what happens if I were to decrease, let's say, the concentration of A? So I've got 3 A blocks, but I'm going to decrease my concentration, and I'm going to take out 2 blocks. So now I've got 1 A, 3 Bs, and 3 of my product AB. Now, in order to create AB, an A red block and a B blue block have to collide together. Now, since there's only 1 A block present, the collisions are most likely not going to be as effective on this side. It's going to be more likely that my blue blocks will run into each other. And it's also going to decrease the amount of A that I have, just simply because there's not as much of it. And so if these two were to collide, for instance, my concentration of A would completely go away, which means that I wouldn't be producing this product over here as readily as I was before. Now, luckily, this system is at equilibrium, right? So even though on this side, just to put these back here, remember I decreased the concentration of A. So there's 1 A and 3 Bs. So we know that this side is not going to be as effective, and we're not going to be having collisions that will create a product as readily as we were. So this side's kind of slowing down, if you want to think of it like that. But over here, where the purple blocks are, this side of the chemical reaction is functioning the same way that it did originally. There's no difference. AB, purple AB, is going to collide together with each other. When they collide together with each other, we have individual A's and an individual B's created. And when that happens, when you have individual A's and individual B's created, notice that I really increase my concentration of B. So the rule says that if the concentration decreases, then the equilibrium will lean towards that chemical species. So what it's saying is that this side of my chemical equilibrium, the side that I didn't touch, this side is still functioning the way that it normally would. So we have these 2 purple blocks that collided together, and they're still creating individual A's and individual B's. So the concentration on this side is still going to be doing the same thing that it did before. But my A's, I artificially removed some of them, so they decreased. So their number is going to go down. And my B's, their number is going to increase because there was more of them to begin with, and my purple AB blocks are still functioning, still creating more of them. And since there's less A's, there's going to be less collisions between these two, creating new products. So when concentration decreases, the equilibrium is going to favor whichever side of the chemical reaction the decrease was on. Because the opposite side of that chemical reaction, in this case my purple AB, will still function the way that it did before. So it'll still collide, it'll still combine, or those collisions will still lead to the formation of, in this case, the reactants. But because I've changed the ratios on this side of the chemical reaction, this is not as effective as it once was. Hopefully those helped you understand Le Chatelier's principle a little bit better and what they're talking about when they refer to these rules.